run in three modes. On the first mode, you'll provide values of HLRP, CHR, and percent airflow. The second mode, you'll provide values of loads, cooling load, electric, and heating load. You can also modify the subsystem's efficiency. On the third mode, you'll have the same as the second mode, but you can run it on multiple times. The program layout, you'll have to the left the input parameters, where you can modify the values accordingly to the load settings. The electric load settings to the right of that, where you can add solar PV and storage and electric load. This is only available on the advanced mode. To the bottom of that, you'll see the load and export buttons, where you can add the table containing different load profiles as a function of time. There is also the advanced and the read file settings, where you can click on those to toggle between modes. The bottom called run is basically used on the three modes to run the simulation. You can also see the graphs and the text boxes in which the answers and results of the simulations will show up once you have selected and given the input parameters. We're going to try our first mode, in which you'll have a demand of HLRP of 5, a CHR of 0, and a percent flow of 100%. Just give the values to the respective text box and click on run. You'll see that the graphs plot the answer, and to the left it's tagged on a text box. For this case, you get an EUF of 0.67. For our second mode, we have the loads given by the user, which means in this case we have these values. We're gonna transcribe them to the interface and make sure that the efficiencies are also accordingly changed. If you do not know these values, we suggest to leave the ones that are predefined. So we have a solar PV output of 200, an electric load of 1000. There's no cooling load, so that would remain as 0, and there's a heating load of 500 kilowatts. The plant capacity should be larger than the demand. The demand is basically the electric load and the cooling load divided by the efficiency and the COP respectively. The predefined efficiencies for the generator, the COP, and the furnace will remain the same. So after all the parameters are inputted into the program, once again click on the command run and wait and see until you get the answers plotted and written on the text boxes. For the final mode, it will be the same advanced mode running as time domain multiple times. So for that, you'll need to provide a table that looks like this one, where you have a time, electric load, a heat load, a cooling load, a PV, and a storage load, all in kilowatts. Be careful of the format, especially of the headers. They are case sensitive. Please consult the user manual for more information on this. Once the table has selected, you'll see that it'll show up on this text box right here. It'll contain the path where the file is saved. Now, to pre-process that file, click on read file. You'll notice that a graph will come up plotting the values which you just gave to the program. You have a heating load in red, an electric load in green, and a cooling load in light blue. This electric load would subtract the PV output and the battery storage. So these are the values that are going into the cogeneration facility. You can also modify the plant capacity, the generator efficiency, the COP, and the furnace efficiency. Please select on which values you would like to plot on the graphs below. So in this case, we're having EUF and CO2 production rate as a function of time and as a function of HLRP. Once you're ready, click on run and wait for the results to come up. As you can see, for the time domain, you'll see the EUF average and the CO2 average. The HLRP has no average, but you can see the results. In case you would like to see the results and analyze them on a program of your own, click on the export button, where you would be able to save these results as a table